Hello, this is Mr. Kinyanola. I'm going to show you how to find the area of a regular hexagon when they give you one of the side lengths. So, look at this hexagon, 1, 2, 3, 4, 5, 6. And we want to figure out how many squares fit inside of this hexagon when each side is 12. Okay, so it's regular, so every side is 12. Now, there are two tools that we're going to need to reference. The first tool is, I know this is a hexagon, but we need to know that the area. So let's write this down. And at any point during this video, because there are a lot, not really a lot, but there's a number of steps that you have to follow. If you need to press pause, you need a timeout, you need to rewind any part so that you don't miss anything, please do so. Okay, so there's many steps. It's like building a house. We need many steps to build a full house. So to figure out the area of this entire hexagon, it takes a few steps. All right, so the first tool that we need is to remember the area of a triangle. And the area of a triangle is A is equal to base times height divided by 2. Okay, I know this is a hexagon, but we're going to reference that. And the next tool that we're going to need to remember is this type of triangle. It is a right triangle, and it is these 30, 60, 90 triangles that you probably learned a few months ago or a few weeks ago, or you just, hopefully you learned it. But if you remember 30, 60, 90 triangles, here is the 30, and its opposite side is this short side. This is the shortest side because it's opposite the smallest angle. So that's looking at this side. So this would be X. This side right here is the middle side because it's opposite the middle angle. So 30, 60, 90. This is in between the 30 and the 90. So this would be X, whatever the short side is, times square root of 3. And this side is the hypotenuse because it is opposite the biggest angle, that 90. And the hypotenuse is 2 times as much as the short side, so 2 times x. So these are the two tools that we're going to need in order to figure out how many squares fit inside of this hexagon where every side is 12. So here's how we're going to do this. Well, our first tool is the area of a triangle, so we're going to divide this up into triangles. So I'm going to estimate where the center is at. So I'm estimating it's right about here. And I'm going to take my ruler and just divide it up into triangles. So from that center to here, it's not quite the middle there, but there you go. And at this point, I don't know if it's really, that's the vocabulary word for center, but yeah, in the middle somewhere right there. Okay, where all of these, center, where all of the radii of this hexagon meet. So from point where the vertex meets, all of these meet there. Okay, so 6 triangles. Now, here's the concept. If we can find the area of one of these triangles, and all of these triangles are congruent because this is a regular hexagon, if we found the area of one of these triangles, we can multiply it by 6, and we'd have the area of this entire hexagon. Hexagon is 6 sides, which has 6 angles, and also 6 congruent triangles. Okay, so we need some other lengths here. Okay, so we got that. So if we find the area of one of these triangles multiplied by 6, we get the area of this entire hexagon. That's why we're trying to remember, or we're referencing this formula. Area equals base times height divided by 2. All right, so let's focus on this one triangle down here. And can we figure out any of these angles? Well, yeah, we can technically if we remember that all the way around okay, is 360 degrees, right? A circle is 360 degrees. So if we rotate all the way around, that would be 360 degrees. And if I wanted to know just the measure of this one angle right here, it would be 360 divided by, how many of these angles did we split up? 1, 2, 3, 4, 5, 6. So divided by 6, and that's 60 degrees. So this angle, remember, we're just going to focus on this one triangle down here. This one angle is 60 degrees. Okay, now, if you need to pause, again, if you need to pause and rewind, do it. All right, so area of a triangle, base times height divided by 2. But remember, the base and the heights are always perpendicular. That means they make 90-degree angles. So this side right here and this side right here, this line and this line are not perpendicular because they don't make a 90-degree angle. This right here is not 90 degrees, but we can always draw one. Okay, so I'm going to take my ruler and I'm going to draw a line that is perpendicular to this right here. Okay, and so now we have our base right here. Here's our base, and here is our height, because this height is perpendicular to this line right here. So if we can figure out the length of this side right here, this height, multiplied by this base and divided by 2, we'd have the area of this triangle, and then we'll multiply it by 6, and we'll have the area of this entire hexagon. Following with me? You got it? So we got the 60 degrees because we split up this 360 divided by 6 to get that 60. We need this height right here because we need the height to be perpendicular to this base. Once we figure out this, we'll multiply by this and divide it by 2, which will give us the area of one triangle. We'll multiply it by 6 and get the area of this entire hexagon. So how do we figure this out? Well, in drawing this line, we split this 60-degree angle in half. We bisected it. So that angle now is 30 degrees. And we're going to focus on this triangle right here. Now, if this is 30, okay, so I'm going to focus. Right now, we're going to focus on this triangle, which is half of this triangle. If this is 30, then this has to be 90 because that's perpendicular. And if this is 30, this is 90, and this is 60 degrees. Okay, so now you see why we had to remember our identity, our facts about 30, 60, 90 triangles. Okay, so for now, since we split this entire hexagon into 6 congruent triangles, and we split this one triangle in half because we want to figure out what this height is. So I'm going to highlight it. I'm just going to highlight that, and we're going to focus on this half of a triangle. Okay, so all these colors. It's great to have different colored markers. Because we split this triangle in half, so the length from here to here, just from here to here, is 6. Okay, and because now that we've identified this triangle to be a 30, 60, 90 triangle, this right here in this 30, 60, 90 triangle, we're just focusing on this one. This is opposite the 30 degrees, so this is the short side right here, and we want the height right here, this right here, and because it's opposite the 60 degrees, this is the middle side. And if we remember, what do we know about the middle side, the side that's opposite the 60 degrees? It's just the short side times square root of 3, or radical 3. So if this is 6, this has to be 6 radical 3, or 6 square root of 3. All right, now let's zoom out and just focus on now this triangle right here. This big triangle. Okay, now we have everything that we need to find the area of this big triangle. We have our base, which is 12. We have now our height, because we split this triangle in half in order to get the length of the short side, because we have a 30, 60, 90 triangle. Short side is 6. And now we have the height, which turns out to be the middle side in a 30, 60, 90 triangle, which is 6 square roots of 3. And we're going to divide that by 2, because we want to find the area of a triangle. So base is 12. Height is 6 square root of 3 divided by 2, because it's a triangle. So let's figure this out. Now what I'm going to do is, we want to leave this square root of 3. So I'm going to just multiply this 12 times 6. And then I'm going to divide it by 2. Is 36. And remember, we're just going to leave that square root of 3. So simplified, it's 36 square roots of 3. And this is the area of this one triangle. But remember, our goal is to find the area of this entire hexagon. So if this is 36 square root of 3, this is 36 square root of 3, 36 square root of 3, 36 square root of 36. Okay, so now in order to find the area of this entire hexagon, we're going to take the area of one triangle and multiply it by 6, because we have 6 congruent triangles. And so 36 times 6 would be 216 square root of 3 units squared. Oh no, it's feet. So feet squared. So there is our final answer. 216 square root of 3 feet squared. That's how many squares would fit inside of this entire hexagon when every side is 12 feet. So let's do a quick review. We have a hexagon. We split it up into 6 congruent triangles. We figured out that each of these central angles, these are called central angles because they're in the center. And so it's just 360 divided by 6, which is 60 degrees. And we want to find the area of this one triangle. So we needed the base, which is 12, this entire thing, but we needed the height. And we drew this line because this line is perpendicular to this base. And in drawing this line, we split it up into 2 triangles, and each of these triangles ends up being a 30, 60, 90 triangle, because when we drew this line, it bisected this 60-degree angle to be a 30-degree angle. And because this is 30 and this is 90, because it's perpendicular, this is a 60-degree angle. So 30, 60, 90 triangle. And we remember that with 30, 60, 90 triangles, that the side opposite the 30 is a short side. And this short side is 6 because it's just half of this right here. And then the middle side opposite the 60, which is the important side because it's the height, is the short side times square root of 3. And so we find the area of our triangle, which is the base, which is 12, times the height, 6 square root of 3 divided by 2. And when you simplify that, that's 36 square root of 3. And that's the area of one triangle. And then we multiplied it by 6 right here. And our final answer is 216 feet squared. All right. There's your answer. So that's how you find the area of a regular hexagon. So let's do another one. And try this one on your own. Press pause and try it on your own, and then press play and see if you have the same answer as I do. So every side is 30 feet. So I'm going to put a 30, 30, 30, 30, 30, and 30. and I'm going to split this up into 6 congruent triangles with my ruler. So I'm just going to draw a line that goes there. I'm going to draw a line that goes there, and I'm going to draw a line that goes there, and they all meet in the center right there. And remember, all we're going to do is focus on one triangle. We're going to focus on this one triangle, and this angle right here. All these angles are 360 degrees. 360 divided by 6 will be 60 degrees. And let's use a darker color. So let's make this in red, 60 degrees. And we want to find the area of this one triangle, which is base times its perpendicular height. All heights are perpendicular. So we're going to draw the height. So a line that goes straight down, and when we draw that line, it bisects this 60 to make this angle right here 30 degrees. This is degrees, this is in feet, so that you're not confused. And we have a 90 right here, and we're going to focus on this right here because we need this height right here. So if this is 30, this is 60, so this has 90. This has to be 60 degrees. Okay. And the length from here to here would be 15, because in drawing this height, it also bisects this base in half, so this is 15. And because that is opposite the 30 degrees over here, and this has to be the short side, this right here has to be the middle side, and because this is a 30, 60, 90 triangle, the middle side is just the short side times square root of 3. So this would be 15 radical 3. Now we have everything that we need in order to find the area of this one triangle. We have the base, which is 30, times the height, which is 15 square root of 3. And we're going to divide that by 2. Because that's the area, the formula for the area of a triangle, base times height divided by 2. And we're going to grab our calculators, and we're going to leave it in radical form. So we're not going to multiply it by square root of 3. So we're just going to leave it in radical form. So 30 times 15 and divide it by 2, which is 225 radical 3. So that is the area of one triangle. And how many of these triangles fit inside of a hexagon? Well, it's a hexagon, so that's 6 sides. So we're going to multiply this by 6. So 6 times 225 radical 3, which is 225 times 6, which is 1,350. And don't forget that radical 3, or square root of 3 feet squares. So that is how many squares fit inside of this hexagon. There you go. That's how you find the area of a regular hexagon when you're given one side. All right, one more example. Press pause and try this on your own. Okay, so find the area of this regular hexagon when the apothem. Wait a minute. Okay, so what does apothem even mean? So the apothem is just a different measurement. So, but it's all the same steps. So let's draw our lines that divide, that split this hexagon into 6 pieces. Okay, and all 1, 2, 3, 4, 5, 6 radii meet in the center. Now, apothem is just another word for height of one of these triangles. So right here, that would mean that this right here, this is 15. Okay, and remember, all of these angles are 60 degrees, and when we split it up, this whole 60 turns into a mini 30 degrees. So we have our height. We're trying to figure out this base now. Well, here's our 90. Here's our 60. This 15 is the middle side. And if you remember the shortcut, the middle side, in order to get the short side, it's working backwards. You divide this by 3 and multiply it by square root of 3. So this would be 5 square root of 3, or 5 radical 3. Because if we multiply this by another radical 3, we would get 15. And there's the rule for 30, 60, 90 triangles. Okay. If you need a review on that, find my video on 30, 60, 90 triangles. Okay. And so now, if this from here to here in this triangle that we're focusing on is 5 radical 3, this right here has to be 5 radical 3. And that means this entire thing, this length right here of this regular hexagon is 10 radical 3. Okay. So we have the apothem, which is the height of one triangle, which is 15. Because this is a 30, 60, 90 triangle, from here to here would be 5 square root of 3, using the facts about 30, 60, 90 triangles. And then times 2 would be 10 square root of 3. That would be the length of this entire side of this hexagon. Now we have everything to find the area of this one triangle. It's 10 square root of 3, which is the base, times 15, which is the height, or the apothem, divided by 2. We're going to grab our calculators. So 10 times 15 divided by 2, which is 75 square root of 3. Let's make that 5 look nicer. So 75 square root of 3. So that's the area of one of these triangles. And we know that there are 6 congruent triangles. So 75 square root of 3 times 6. Let's put parentheses, times and parentheses. 75 times 6 would be 450. And please don't forget that square root of 3. Let's leave it in radical form. Yards squared. And that is how you find the area of a regular hexagon when you're given the apothem. Okay. All right. There you go. That's how you do it. Have a great day.